Sometimes it might not be possible for you to target external APIs for using GenAI models, large language models, or traditional machine learning models. Whether that could be something related to data, security, or the current policies, it all falls or leads to one roadblock, which is not being able to utilize your own data on GenAI models. There are multiple approaches that could be followed in order to resolve this roadblock. One of them is using models locally. There are multiple approaches or products that allows you to utilize or use locally deployed models. One of them is vLLM. vLLM stands for Virtual Large Language Model, and it runs on top of a fast API application server. What is more important with that is it uses a specific mechanism that allows you to serve concurrent users at the same time. So in this video, what I will be doing is that I will be showing you, based on my previous experience with vLLM, how useful it is for deploying local models, running that within the internal network, allowing serving different concurrent users. At the same time, using GPU utilization to utilize the GPU in deploying multiple instances of vLLM servers. I will also show you how we can utilize both LangChain and OpenAI in order to target both large language models and audio models deployed using vLLM servers. To give you a quick overview about vLLM, it is a high throughput and memory efficient inference and serving engine for LLMs. As you can see, it started with enabling large language models only. vLLM follows an approach named paged attention, and that approach allows you to utilize concurrent users on the same GPU or serving multiple users at the same time. If you have a GPU that can fit the size of the models, then everything should be straightforward. From your current environment, start by installing vLLM simply by pip install or UV or conda install. Once that's successfully finalized, you can download model weight. At this stage, I have a 40 gigabytes GPU, so I downloaded Llama 3.1 Instruct 8 billion. Here is an example showing the successful download of the required files into a local directory. So, deploying a model via vLLM is easy and straightforward. I mean by that, once you get all your files ready, once you install the library, the next step is to start serving the model. And to do that, simply get into the CMD and type the following command line, making sure that you point to the model files and setting up the required port and so on. Once everything started properly, you will be able to see the following. And similar to fast API applications, you'll be able to utilize docs in order to check the current services available for use. You can do that with your local host or with the IP address of where the server is deployed. You can see here with no GPU utilization being applied, most of the available memory, the 40 gigabyte GPU, will be acquired by the Llama 3.1 8 billion Instruct model. So you can see that the Llama 3.1 8 billion model is now deployed via vLLM, and it can be used in serving users. Because we are using vLLM and there is paged attention at the backend, this means multiple concurrent users can utilize the deployed model. One possible approach for targeting the internal APIs is LangChain. LangChain is a powerful library used for building AI-powered applications. And combining it with vLLMs means that you can build and deploy apps without going to the external network. Simply downloading LangChain, then using Chat OpenAI in order to target the model, then putting the URLs, not putting in here any API keys, adding and removing verification for dev purposes, creating the prompt here, doing some entity extraction, and then invoking the LLM. You can see the results in here showing like the number plates and the vehicles. This is similar to what you will be doing when you target external APIs. So you can see how vLLM can handle your roadblocks via using locally deployed models. Sometimes you want to deploy multiple models at the same time utilizing the same GPU. You have seen in the previous example, we had an 8 billion model and we utilized 37 gigabytes out of the 40 gigabyte GPU memory. But with vLLM servers, it is possible to reduce the required memory or the taken memory in the GPU by doing GPU utilization. GPU utilization tells the vLLM instance how much to use of the memory, and it is allocated from the command line. So you can see here on the left-hand side, we had the original approach. Then with using GPU utilization, we can basically minimize or reduce the amount of memory taken by the GPU for a specific instance. To show you like the capability of vLLM, I took the decision to go through and show you how we can utilize Whisper model, which is used typically with audio, and deploy it via vLLMs. Using Whisper on vLLM comes with its own limitations at this stage, but definitely it can be used for full transcription of audio files into text. Similar to what we have done with the LLM, we download the model weights, then we use a command similar to what we have done with the Llama 3.1 Instruct. Now we have two models, one large language model and a Whisper model running on the same GPU because of GPU utilization. Checking the GPU, it is showing that the two models are currently deployed and utilizing almost 2/3 of the GPU. Let's check this example for using the Whisper model via vLLM to do transcription. Here is a sample of the audio file.
Mr. Quilter is the apostle of the middle classes, and we are glad to welcome his gospel.
With OpenAI library, we can target the locally deployed vLLM server in order to do transcription of the audio files. And you can see a sample of the results in here.
Mr. Quilter is the apostle of the middle classes, and we are glad to welcome his gospel. Nor is Mr. Quilter's manner less interesting than his matter.
In this video, I tried to show you how we can utilize one approach, which is vLLM, to deploy models locally in scenarios where we can't push the data outside the current network. It was once said that lots of ways lead to heaven, and this was one quick way to enable serving large language models and other types of models on-prem. Definitely there are other different approaches that are worth being investigated too. One of them is Llama. With that being said, thank you very much for watching.